Good afternoon. Welcome to the Endeavour exhibition. I'm the team leader, David.
I'm Ivy.
I'm Jeremy. Our topic is 5G use case demonstration, remote controlled robotic arm with haptic feedback and real-time video streaming. We're building such a system demo for the application inspired by the advantages of 5G in collaboration with the industry partner Ericsson. Firstly, please let me invite one of our team members, Peter, who is unfortunately not able to be here, to give a brief introduction of 5G.
Ever since the advent of modern society, the speed of technological development has always depended on the speed of information transmission. The 5th generation mobile network is the latest area of exploration at this stage. With the development of 5G, network slicing allows internet service providers to better target their limited resources to provide more appropriate network service to clients with different requirements, such as providing higher speed and lower latency. Because of this advantage over the 4G network, tasks such as remote surgery and remote bomb disposal, which previously required the presence of experts on site, can now be performed using 5G to build a high-precision, gesture-based remote control system with haptic feedback and real-time, high-definition video streaming.
Thanks, Peter. Let's now focus on the design strategy of our demo.
To realize such a system, one of the key points is to capture arm movement. The motion tracking sensors are chosen to do the job, which can measure the gravitational acceleration and angular velocity. By placing two sensors on user's hand and forearm, the measured data can be collaboratively utilized to compute the roll, pitch, and yaw of users' each joint. That information could then be used to control the 5 motors in our robotic arms to simulate the corresponding motions. The roll and pitch of the wrist are taken care of by the 2 motors here. Another 2 motors are placed here for simulating the pitch and yaw of user's elbow. We have another motor in the middle, which enhances its ability to follow users' motions. But to fully simulate the actions of user's hand, we also need control of fingers. As you can see, our robotic arm has a clamp controlled by a motor here, which could just be used to simulate the thumb and the index finger. To obtain the information of fingers' movement, a flex sensor is tied to user's finger, whose resistance will change as it is bent.
In order to complete this system, we also need to deliver the haptic feedback to the users. A simple way to realize this is to use the force sensor resistors and the shaftless vibrators. Once the clamp touches the object, the resistance of the force sensor resistor attached on it will change with the force applied on it. The pressure signal therefore could be used by the vibrators attached on the user's fingers for generating different levels of vibrations, which represent for haptic feedback. Next, David will talk about how the whole system works. Thanks, Ivy and Jeremy. Our system uses 2 Raspberry Pi as processors of each terminal. The 2 Pi's clients will firstly collect and compute all sensed data and send them to a network server. The server would then pass them to the destination terminal. Also, a real-time video will be captured by the camera and encoded by the Raspberry Pi connected to it, so that the Raspberry Pi on the other terminal can be able to decode and play it on its screen. Next, we'll be giving a brief demonstration of our system. Now, we've already connected our 2 terminals to the 5G network, and they're communicating with each other through a network server we rent in Sydney. I'm trying to place the toy block into the red box while looking at the screen. As the incomplete Australia 5G infrastructure is still not much different from 4G, what we do is to manually add extra delay to illustrate how the network quality influences the system. This could also be treated as a simulation of the 5G network slicing technology, where better networks could be sliced for the use cases in need. with the bad network, the system is very difficult to be controlled and the video quality is not guaranteed. Our system is just a demo. It has its limitations. For example, the movement is not smooth due to the motor quality, and the feedback approach is far from realistic. We used it to successfully complete several tasks, such as drawing simple shapes and stacking toy blocks. In real-world applications, it can be designed to be expensive or cheap depending on the requirements, and specifically modified to fit some use cases. If you are interested in our project, please come to our table for any further discussion. Thank you for watching.